Good morning, students. Myself, Vijay Shankar from BC Department, Chevron Engineering College. Today also we are going to discuss about the inverse Fourier transformation examples. In the last class, we discussed the Fourier transformation examples, and now you can see another Fourier transformation and inverse Fourier transformation examples. Here, the application of the Fourier transform of the network analysis. Try to find out the Fourier transform by using the given network. Determine the voltage V out to the current source existing excitation, not existing excitation of I of t is equal to e power minus t mu of t. The given I of t, the current I of t is equal to e power minus t mu of t. And you have to find out the V out is equal to V out of t is equal to from this given network. Okay. See, from I of t, the I of t passes through this resistance and the capacitance also. So what is the equation? I of t is equal to I1 plus I2. I of t is equal to the current I1 plus I2. I1 of t plus I2 of t. So what is the current in terms of the voltage? The V by R. You know the I is equal to V by R through the resistance, and I is equal to the current that is passes to the capacitor C into dV by dt. C into dV by dt. The current I is equal to. If suppose it is through the inductor, I is equal to integral I into the dt of 1 by L is there. In terms of the inductance, I is equal to C into dV by dt, and I is equal to V by R here itself. The derivative part and the integral part for the inductance 1 by L into something. Now I can use this is a current through the resistance. The current I1 is passed V by R. What is the V? Is nothing but here the V out. V out of t whole divided by the R. R is here the 1 ohms only, the 1 plus I2 of t is passes through this capacitor current C into dV by dt. What is the C here? The 1 by 2 dV by dt. dV out by V out of t by the dt. Okay, is the I of t is equal to. So what is I of t given? E power minus t mu of t. E power minus t mu of t is equal to V out V naught. I am taking the V naught of t plus 1 by 2 into, right, this is a 1 plus 1 by 2. Not, it is not the 1 plus, sorry. V naught of t and d by the dt of V naught of t. Okay. Now apply the Fourier transform on both sides. This is a Fourier transform, my students. Fourier transform on both sides. E power minus t mu of t. What is the Fourier transformation of e power minus t mu of t? We know e power minus a t mu of t. E power minus a t mu of t is a 1 by a plus j omega. 1 by a plus j omega. A is here the 1. So 1 by 1 plus j omega is equal to V naught of t is a V naught of omega. How it is? If the x of t is a Fourier transformation is x of omega. The V of t Fourier transformation of V of omega, and the V of t is the Fourier transformation is V naught of omega plus 1 by 2 into the derivative of d by dt of x of t. This is one of the property, time differentiation property in the Fourier transformation. Differentiation j omega into x of omega. Okay, the derivative of time domain function d by dt of x of t is j omega into x of omega. Now apply here also, that is the Fourier transformation of the d by dt of v naught of t is j omega into v naught of omega. Now we can take the common of v naught of omega is 1 plus j omega by 2. And here it is a 1 by 1 plus j omega. Okay. And they are asking that it is a determine the V voltage V naught of t. So what is finally the function, the V naught of omega? So V naught of omega is equal to V naught of omega is equal to, here in the left hand side, 1 by 1 plus j omega, and you can cross multiply this function, the 2 by 2 plus j omega, 2 by the 2 plus j omega. So V naught of t is equal to 1 by j omega, 1 by 1 plus j omega is there. And you can take the LCM here. Here itself the V naught of omega is equal to 2 plus j omega by the 2 plus j omega by 2. So V naught of omega is equal to 1 by 1 plus j omega and 2 into 1 by 2 plus j omega. Therefore, the V naught of omega is equal to the 2 by 1 plus j omega whole multiplied with the 2 plus j omega. Now, by using the partial fraction expansion method, find the a and the b values. A by 1 plus j omega and b by 2 plus j omega. B by 2 plus j omega. That is a V naught of omega is equal. The find that 2 is equal to a into 2 plus j omega plus b into 1 plus j omega. So compare the left hand side and the right hand side equations. Constants, when you compare the constants, 2 is equal to 2a plus b. And you can compare the j omega coefficients. 0 is equal to j omega coefficients, a plus b. A plus b. A is equal to minus b, or b is equal to minus. What did my difference? A is equal to minus b. Let us take it, a is equal to minus b. So substitute here the a is equal to minus b. 2 plus 2 here. So b is equal to the 2 is equal to minus 2b plus b. What is a minus 2b plus b? Minus b. Minus b is equal to 2, or b is equal to minus 2. B is equal to minus 2. When we got the b is equal to, and a is equal to minus b means a is equal to 2. A is equal to. So we got the two functions, A value and the B value. Okay. Now I can substitute in the V naught of omega is equal to. So I'm writing here V naught of omega is equal to A as a 2 by 1 plus j omega, my plus B is minus 2 by 2 plus j omega. Now I can apply the inverse Fourier transformation of this function. V naught of omega is the inverse Fourier transformation is V naught of t plus, not the plus, sorry, is equal to 2 is a constant, 2 into 1 by 1 plus j omega, nothing but e power minus t mu of t from this equation. A is 1 here, and minus 2 into 2 plus j omega means e power minus 2t mu of t. Okay, V naught of t is equal to 2 into e power minus t mu of t minus 2 into e power minus 2t mu of t. Got it, my students? So from the given network, we got the output voltage V naught of t is equal to V naught of t is equal to. Here you can see the V naught of t is equal to, they got this is not the function. V naught of t is equal to 2 into e power minus 2. For this function, the 2 by 1 plus j omega is 2 into e power minus t mu of t. And for this function, the minus 2, the 2 into e power minus 2t mu of t on. Okay. Next example is another one. It is not the answer. It is a 135 page. 134 page is missed, my dear students. So for this function, or for the network given, the I of t is equal to the resistant capacitor, the V naught of t is equal to 2 into e power minus t mu of t minus 2 into e power minus 2t mu of t. Okay. Now coming to the next one. So determine the response of current. Determine the response of current in the network shown in the 2.28a when a voltage having the waveform shown is a V of t given as a half wave only from 0 to pi, half positive, half cycle of sine is applied by using the Fourier transformation. Okay, so first of all, take the V of t. So V of t and the I of t, the equation V of t is equal to I of t into R plus, now it is in the voltage equation. So the capacitor, it is a 1 pi c, the integral of I of t into dt. Okay, first of all, I am writing the equation. When you go for to write the equation of the given network, V of t is equal to IR, I of t into R is a 1 kilo ohms, 1 ohms, that is a 1 plus the voltage equation 1 by C is a 1 farad, the integral I of t dt. Okay, I of t dt. So V of t is equal to, now we got I of t plus integral I of t dt. Both resistance and the capacitance given is only one. Apply the Fourier transformation on both sides. V of omega is equal to V of omega is equal to I of t. I of t is I of omega plus the integral. The Fourier transformation of the integral is 1 by j omega is I of omega into, not the into, by the j omega will get 1 by j omega into I of omega. And here it's saying that it is a v of t is equal to I of t plus 1 into integral 0 to t I of t dt, that is equal to I of t, and the integral 0 to t I of t dt. But taking the Fourier transformation on both sides, the v of t becomes a v of omega, and I of t, the I of t is equal to, they wrote the I j omega whole square plus 1, and integral value, the e power minus j omega pi into omega and j omega whole square plus 1. So let us take that, how we got that function as from the v of t function. Okay, see the half wave here from 0 to pi only, half wave from 0 to pi. The sine t mu of t, sine t mu of t, and the sine t mu of t minus pi. Okay, the first function is Fourier transformation of t into mu of t, and the other function is you get the sine t mu of t minus pi. Okay, from this equation, for the second figure, we got the equation. Let us see that in the sinusoidal function, to get this sine, let us take it is like this sine function 0 to pi and the up to here the 2 pi. Okay, mu of t, or the mu of t is a v of t, the given function, and now I'm taking this as a mu of t function, mu of t sine t mu of t, and you can shift this function as mu of t minus pi. Okay, means it starts from the pi itself. It starts from the pi. Got it, my dear friends? So when it is multiplied the sine t mu of t and sine of sine t into mu of t minus pi. So what is a sine t here? Sine t, sine t into mu of t, the function, we know the Fourier transformation of the sine t mu of t is 1 by sine a t, actually it is sine a t mu of t 1 by a square plus j omega whole square. This is a Fourier transformation of sine t, sine a t mu of. What is the a here is a 1. So sine t mu of t, its Fourier transformation is 1 by 1 plus j omega whole square. Similarly, the sine function, the sine t, is shifted the step function towards the right side with the pi samples. First of all, you can write the time shifter. Shifting means it is multiplied with the e power minus j omega into how many number of samples it is shifted. The t naught samples means it's a t naught. It is a pi. So e power minus j omega pi, and this Fourier transformation is a square plus j omega whole square. A square is a 1 square plus j omega whole square. It is a 2 functions we got from the v of t is equal. Okay. Then after, by adding these 2 functions, the sine t mu of t and the sine t mu of t minus t. adding these two functions, we'll get the V of t is equal to as only the half cycle. As only the half cycle. Okay, my dear students. 0 to 2 pi wave. So V of j omega or V of omega is equal to 1 by j omega whole square plus 1 plus e power minus j omega pi and j omega whole square plus 1. Take the Fourier transformation and you can use the Fourier transformation of sine t mu of t and sine t mu of t minus pi. Okay, my dear students. Now, another one, find the fundamental period of t. Find the fundamental period of t. It is a Fourier series, my dear students. So forget about this. It is also the Fourier series only. Applying the Fourier series, now you can see the Fourier transformation of the gate function. Gate function. Gate function means x of t is a given of magnitude is a from minus t by to the t by 2. So x of omega is equal to a into the value is a e power minus j omega t dt. It varies from the minus t by to the t by 2. Okay. So x of omega is equal to the integral minus infinite to infinite x of t e power minus j omega t dt. E power minus j omega t dt. And that is equal to, what is x of t given? X of t is equal to a from minus t by 2 the t by 2. The x of t is a into e power minus j omega t dt. Okay. And here the integral is with respect to the t, a is a constant, right the outside, and e power minus j omega t is e power minus j omega t pi minus j omega, with upper limit is t by 2, lower limit is a minus t by 2. And what happens here, the a into or a by minus j omega, the upper limit we can substitute e power minus j omega t by 2 minus e power minus j omega minus t by 2. Okay. Now, here the minus is there, multiply this minus omega, and minus is becomes is a plus, minus into minus is a plus, j omega t by 2. And this positive function becomes a negative, e power minus j omega t by 2. And j is there. Now I'm writing here the 2j, multiplying the 2 here. Okay. Now observe, is a function of sine 2a by omega e power jx plus minus e power minus jx by 2j is a sine x, sine omega t by 2. Sine omega t by 2. So this is a function we got 2a by omega sine omega t by 2. To write this as a sinc function, add, not that, multiply the t by 2 here, t, and this already the 2 is there. Bring that 2 in this here itself and remove the 2 there. Now it becomes of 2a by omega t. So t is multiplied, and now you can take multiply and divide. So at, and now the sine omega t by 2 by the omega t by 2. Okay, means sine omega something and sine omega theta, sinc theta or sinc t. Following my dear students, AT into, and this function is a sinc function. How it is a sine. Now I'm changing this as sine omega is a 2 pi f into t by 2 whole divided by 2 pi f into t by 2. 2 to get cancelled here. It is also the 2 to get cancelled. Sine pi ft by pi ft. Okay. Sine pi theta by the pi theta is nothing but sinc theta. Sinc theta. Now the x of j omega or x of f is equal to at a into capital T. 2 sine pi theta by pi theta is a sinc function. Sinc f into t. Okay, whatever the multiplication factor of pi is there, sinc theta. Here the f is multiplied, pi is multiplied the ft. X of f is equal to at into sinc ft. The gate function Fourier transformation. Okay. Now, the Fourier transformation of the given graphical representation from minus b to the b, minus b to the b. In this, you can take the three cases. Previously, we did one rectangular function. The Fourier transformation of not the rectangle, triangular function. You can find out the slope of this one and the slope of this, slope A and the slope B. And with the limitations of minus b to the b, whatever is the minus t to the t, minus t to the t. Now here, the slope is a, and here the slope is b, and in between of minus a to a, it is a constant. That is a 1. Now what is the slope here? Slope of slope a, and here the slope b. A point on the x-axis means there is no any point on the y, 0, minus b to the 0. And this value is at minus a, the value is 1. Means a point on the y-axis, the value is 1, and here the x is a minus a. At minus a, the value is 1. So using these two functions, x1, y1, x2, y2, x2, y2. What is the slope here? y2 minus y1 by x2 minus x1. What is a y2? y2 is a 1 minus y1 is a 0 whole divided by x2 minus a, x1 is a minus b, already the minus is there, it's a plus. That is equal to 1 by b minus a is a slope. 1 by b minus a is a slope. So what is the equation? Y minus y1 is equal to, the slope is 1 by b minus a into x minus x1. This is the slope equation. What is the y here? The y is x of t. X of t, and the y1, what is the y1 is a 0. Minus 0 is equal to 1 by b minus a. What is the x here? X is a t variable. The t minus x1. x1 means minus of minus is a plus b. Therefore, the x of t is equal to t plus b by b minus a. We got that is the first one. In the range of minus b to the minus a, the slope is t plus b by by b minus a. Okay, this slope equation, and minus a to a, the value is unknown, and a to b, means the slope equation of the b here. Now the y x2 y2, what is the values of x2 y2? Y2 is a 1, x2 is a comma 1, and here the term is in the x-axis, y-axis is a 0, so b comma 0. This is x1 and the y1. Now I have to find out the slope of this is slope equation of a, and now the slope equation of the b. So y2 minus y1 by x2 minus x1 is the slope. M is equal to, what is a y2? 1, y2 minus y1, y1 is a 0, whole divided by x2 is a minus x1 is a b, a minus b. The slope is 1 by a minus b. So what is the slope equation? The straight line equation is a y minus y1 is equal to 1 by a minus b into x minus x1. Y minus y1. What is the y1 here? It is a 0. Y is nothing but x of t. X of t minus 0 is equal to 1 by a minus b, and x value is a t variable, so t minus x1 is equal to b. So the x of t is equal to, we got t minus b by a minus b in the range of a to b, in the range of the interval of a to b, this one, and this is interval between the minus b to minus e. Got it, my dear students? And now find the Fourier transformation of the given function with x of t is equal to t plus b by b minus a, and the x of t, the integral value, let us take it as x of omega is equal to the first integral. Now I take the minus b to minus a. What is the x of t? T plus b by b minus a into e power minus j omega t d. Find the Fourier transformation of this function, plus and integral minus a to the plus a. The x of t is equal to 1 into e power minus j omega t d. Plus third integral is a to b. What is the x of t here? The t minus b by b minus a into e power minus j omega t d. Simplify this equation. You'll get x of omega is equal to 2 by omega square b minus a cos omega a minus cos omega b. Okay, my dear students. Now, I will explain that also, doing all these functions. For the first integral, see, for the first integral minus b to the minus a t into e power minus j omega t. Leave it, that is a 1 by b minus e. 1 by b minus e is a common term. Okay. And here itself only the another integral minus b to minus a, b into e power minus j omega t d. b into minus a, b minus a to minus b, b into e power minus j omega t dt. So apply the by parts here. T into e power minus j omega t pi minus j omega and minus the integral of apply the derivative of t and e power minus j omega t by minus j omega with the upper limit is minus a and lower limit is minus b. Again here the another integral is there, t into e power minus j omega t by minus j omega and minus into minus is a plus. And again here the another time the integral e power minus j omega t by minus j omega whole square with upper limit is minus a, lower limit is a minus. Got it, my students? And for this function, substitute a as wherever the t is there and substitute the b wherever the b is there. And for this second one, e power minus j omega t is plus b into e power minus j omega t by minus j omega with upper limit is minus a and minus b. So b into, and here both the functions is multiplied with b1 by b minus a also. B into e power minus j omega t by minus j omega. The upper limit is minus a minus b. Substitute and simplify this one. And here also a to b is there. A to b e power minus j omega t. And for this function, this 1 by b minus a is both multiplied. Plus here e power minus j omega t by the minus j omega. With the upper limit, you can substitute here. This is a and the b plus. And in this function also, there is you get the two integrals. One is a b minus a. B minus a, not the b minus a, it's a t minus b, a minus b. Is a minus b. Okay. So take the common term of a minus b whole multiply with the same function, but integrals is limitations is different. T into e power minus j omega t by minus j omega plus e power minus j omega t by minus of j omega whole square with upper limit is a, not the a, b, and lower limit is a to b. It is a minus b to a, minus b to a, and b minus a to a. It is a minus a to a, my students. Minus a to a, this one. And this is a to b plus. And here the minus is there, minus b into e power minus j omega t by minus j omega. And you can write it is also the b to a whole multiply. Now substitute all the terms and simplify. You'll get x of omega is equal to 2 by omega square b minus a cos omega a minus cos omega b. I will get the cos function means e power plus j omega t and e power minus j omega t by 2 function. Okay, simplify, you'll get the same. Next one, my dear students, here. Good morning, students. Myself, Vijay Shankar from EC Department, Chippewa Engineering College. Today, we are going to discuss about some more examples in the Fourier transform and the inverse Fourier transformation. So, determine the Fourier transformation of x of t is equal to x of t is equal to t into mu of t with the convolution of mu of t minus mu of t minus 1, where mu of t is a step function and denotes, and asterisk here the star is there, denotes the convolution operation. Okay, in this x of t, the first part you can take as x1 of t with the convolution of x2 of t. What is the x1 of t? x1 of t is a t into mu of t. And another one is there, x2 of t is mu of t minus 1. Mu of t minus 1. Okay. So what is the x1 of t? The convolution. The time is convolution. The frequency is a protector. According to the convolution time domain, x1 of t with the x2 of t, its Fourier transformation is x1 of omega into x2 of omega. According to the convolution time domain. So what is the x1 of t convolution? Not the convolution. x1 of t, the Fourier transformation is x1 of omega is equal to mu of t, the Fourier transformation is 1 by z omega. When the t is multiplied, the total is a square. So mu of t, the Fourier transformation is 1 by z omega. And if it is a t is multiplied for every function, the e power minus at mu of t also, the total function is becomes a square, the 1 by z omega whole square. Okay. And x2 of omega, the x2 of omega is equal to, what is the mu of t? Mu of t minus 1. So mu of t, you can write this in terms of the graphical representation. Mu of t is equal to 1 from 0 to infinite as a t is variable. And the mu of t minus 1 means shifting one sample towards the right side is 1 from 0 to 1. And is a subtraction of the two functions. 0 to 1, the value is 1 here, and 1 to infinite, both the values are 1. So you'll get the gated function. The x2 of t varies from the 0 to 1 only. 0 to 1, the value is a 1. Now, to write this, the x2 of t as x1 of omega is from 0 to 1, the x2 of t is 1 into e power minus j omega t. That is equal to e power minus j omega t by minus j omega, with upper limit is 1 and lower limit is 0. So minus 1 by j omega you can write here. And this becomes of, first of all, you can substitute the t as 1, e power minus j omega, minus second term, the value is a 1. Okay, multiply this minus inside, it becomes of 1 minus e power minus j omega by j omega. x2 of omega is equal. Okay, and we got the x1 of omega is 1 by j omega whole square, and x2 of omega is equal to 1 minus e power minus j omega by j omega. So multiplying the two functions to get the x of omega is equal to numerator as having e power minus j omega and the denominator here j omega whole square and j omega, both it becomes a j omega whole cube. So for the given x of t, using the convolution operation, the x of omega we got 1 minus e power minus j omega by j omega